Hi guys, this is Mrs. Gassler, and in this video we're going to be talking about valence electrons. Now, valence electrons are something that's going to come up pretty frequently in chemistry class, and this is the first time we're going to come up with it and talk about it, but we're going to come back to it later and fill in some more details. So this is going to be a real basic kind of overview of what valence electrons are. I've got some Cornell paper here, and I've kind of pre-filled them out just a little bit, and so if you need to stop to write things down, go ahead and pause the video and then start it back up when you're ready. First off, we've got two essential questions. What are valence electrons? And how do I figure out how many there are? That's the first question. And then, how do I find out what ion charge they're going to get? So hopefully you've already watched a video about ions and what makes it an ion. In this video, we're going to talk about how to figure out what charge it will have based on the number of valence electrons, okay? So, first off, what's a valence electron? Well, valence electrons are those that are in the outermost energy level, okay? Now, we talked before about the Bohr model of the atom. He's got the electrons arranged in energy levels, and the ones that are in the outermost energy level are the valence electrons. So just to draw you a little picture here, you got your nucleus in the middle with your protons and your neutrons, and then your electrons are in these energy levels, okay? So the ones that are on the outermost energy level, that would be these guys right here, those are your valence electrons. They're on the outside, okay? Sometimes we call that the highest. If you think of this as the ground, the highest electrons, the highest energy level. And then later on you'll be able to see some other ways and how you might draw those pictures and see which ones are valence electrons. But those are the ones in the outermost energy level. The reason they're called valence electrons is because valence is something that goes on the outside. At your grandmother's house, or my grandmother's house at least, she's got some curtains. Somebody you know has some curtains like this with a little thing, a frilly thing that goes over the top of the curtain, okay? Maybe it's kind of fluttered like this, and maybe it's solid and it just covers up the top. That's called a valence. That's where we get the idea of valence electrons. Those are the ones that cover up the rest of the window of our atom here, okay? So they're the ones on the outside. So how do we figure out how many valence electrons there are? Well, right now, we're going to figure this out from a periodic table, okay? And your periodic table is going to be super helpful in figuring this out, and it turns out that's the easiest way to figure out how many valence electrons there are. And so that's what we're going to be using from the periodic table. Now, the way it works here, I've got a generic periodic table here that's not filled out, but we'll go ahead and use that to think about what's going on here. What we're going to be looking at is we're going to look at the number of the tall columns, okay? Oops, columns. Now, I call them tall columns because do you see how they're tall? And these are short. Now, these are all columns, too, in the periodic table. We call these the transition elements, which we may or may not have talked about. I can't remember. But these guys are short. They don't follow the same pattern as the rest of the guys, but there's a way to know the number of valence electrons there, too. Now, it's called the periodic table because it periodically starts over another pattern again. So over here, there's one valence electron. This guy has two. He's an odd man out, okay? We'll come back to him. That's helium, by the way, helium, okay? This guy has one. This guy has two. This guy has 3, 4, 5, 6, 7, and 8. And then we start over again. This guy has 1 and 2 and 3 and 4 and 5 and 6 and 7, 8. Do you see the pattern? This should be easy, okay? This is the number of valence electrons, okay? If you just count 1, 2, 3, 4, 5, 6, 7, 8, tall columns only, then you'll know how many valence electrons there are, okay? That's how many valence electrons there are. See? I told you. That was easy. You can do this, okay? Now, later on, we'll learn how to figure this out from a what's called an electron configuration. We'll talk about that later. You can figure out how many valence electrons there are from an electron configuration later. Sometimes you can look at a drawn model. Okay, that can help you think about how many valence electrons. Again, we'll talk about that one later. But from the periodic table, it's super easy. Okay, you can use that to check yourself later on. So if you need to know, find the column, count the column. That's how many valence electrons. What about these guys in the middle? I'm going to write this. They're generally 2. There are some exceptions, not very many. Sometimes there's only 1, sometimes there's 3, sometimes it could be 1 or 2 or 3, but for now, generally 2. Okay? So now what we have to do is we have to talk about how you figure out the ion charge. Now if you want to stop and make a summary of just how to find the number of valence electrons and add some questions in here to quiz yourself on later, that would be fantastic. But for now, let's talk about how do I figure out the ion charge. Okay, now there's this thing called the octet rule, and maybe if you're familiar with the word octet, it literally means 8, okay? Which we'll come back to why it's called the octet rule in a second. This basically says that atoms are stable, they're the most stable, with what we call a full valence, sorry, I've got terrible handwriting, I apologize, shell, okay? So those valence electrons are in the outermost energy level. They call that outermost energy level the valence shell, okay? If that thing is full, then the atom is stable. It's full when it has 8 valence electrons. And there are some exceptions to this, and we'll talk about there. So that's how you know what ion it's going to form, because it forms an ion to become stable. So we'll jot that down here. Forms an ion to become stable. Okay? It's actually more stable when it's charged than when it wasn't, because those electrons, that valence shell isn't full. Okay? So here's the deal. We're looking for 8, but if you'll remember, some of them aren't very close to 8. I'm just going to fold this right here. Some of them some already have 8. In fact, that's also useful to note. These guys are already happy, and this guy with 2 here, he's the odd man out. He's happy with 2 also. His valence shell is full with those 2 electrons, which we'll talk about later. But these guys are already full. They're already stable. That means they don't make any ions. The rest of these guys are trying really hard to get to 8. And this is where I bring up McDonald's Monopoly. Do you remember the game that McDonald's runs every now and then where you got to collect the stupid little tabs off of your French fries and your drinks? And if you get all of the same set, then you win a prize or something like that. Okay. Well, we're going to play McDonald's Monopoly with electrons. Okay. So it's electrons. Hang on, I forgot this. They're going to gain or lose electrons to become an ion. Okay. So these guys are either going to gain or they're going to lose electrons to become an ion to have their full valence shell. Now these guys over here in the 5, 6, and 7, and 8 range, okay? These guys, 5, 6, 7 electrons, these are your friends that have all 3 of the railroads that everybody else has, okay? They got the B&O, they got the Pennsylvania. What are the other 2 names? I don't remember. But they've got 3 of them, and they just need that one more railroad, and they'll win, like, what, $1 million or a hamburger or something like that, okay? So they've got 3 of them, and they're really hoping they get that 4th one, okay? Now you are, you're the other guy, okay? You're on this end over here, the 1, 2, and the 3. These guys almost have enough. And the 1s, the 2s, and the 3s, valence electrons, they're not even close, okay? You found 1 railroad. There's no way you're going to come across 4 of them, okay? Not even, whoops, close. Okay, so these guys here are going to try, so let's say these guys have a conversation. These guys here are like, oh my gosh, if you just give me 2 more electrons, I will have my 8 and then I'll be happy, okay? These guys here are like, oh gosh, I need like 6 more. What am I going to do, okay? So these guys lose their electrons because, well, they've only got 2, they've only got 1. They're not going to get 8, so they just get rid of them, okay? These guys here, they're so close. Oh my gosh, if they just had 1 more, so they're going to gain. Okay, so here's another blank periodic table. Isn't this fun? So remember, these guys have 1, 2, 3, 4, 5, 6, 7, and 8. Okay, these guys are happy. They've already got their 8. They do not make ions. Okay, these guys have 7. How many more do they need to have 8? 1. So they're going to gain 1. That's a 1 right there. Electron. Okay. These guys right here, they have 6. They only need 2 more. Oh my gosh, they're so close. So they're going to gain 2 electrons. These guys, they're going to gain, 3 electrons. That'll get them to 8. Again, we're trying to get to 8 here. Now, on the other end, this guy, he's got 1. He needs 7. Are you kidding me? He's not going to get 7 from his friends. That's not going to work. He's just going to give it up. He's going to lose 1 electron. Now, who do you think he loses his electron to? If you guessed one of these guys over here, you were right. Now, this guy here, he's got 2. Man, he still needs 6. There's no hope there. So he's going to lose his 2 electrons, okay? This guy here, these guys in here, by the way, they all have generally 2, right? So they generally lose 2. And these guys here, they lose 3 because they're not close enough. Now these 4 guys could go either way. They generally don't form many ions, but often it's of the negative variety, so they generally lose 4 electrons, okay, when they form ions. Now, what happens when you lose something that's negative? Okay, so let's play with that. So these guys here, they used to have no charge. Okay, we're gonna take these guys here. They used to have no charge. Then they lost an electron, which has a charge of -1. Electrons are negative. Okay. Now, when you lose a negative number, what kind of math do you do here? Well, remember, oh my gosh, that pencil's really hard to see. I'm so sorry. Let me, no, that's not making it any better. Okay, these negatives, they cancel each other out. That's like saying 0 plus 1, which equals +1. So when you lose an electron, you become positive. Now let's take a look over here at these guys. This guy is going to gain, starts out no charge. It's going to gain an electron, which is a -1. Okay, and when it gains that negative electron, then what charge does it get? Well, 0 plus a -1 means -1. So when you lose electrons, that's an L, lose electrons, that makes you become a positive ion. You're positive that you lost it, I suppose. I don't know. We call a positive ion a cation. I'm not sure if we talked about that in another video or not, but we call it cation. And these guys over here, when they gain electrons, and maybe you already knew this altogether, they become negative. We call those anions. I like to remember it, a negative ion, and here's the plus right there in the cation. Okay. So that's how you figure out what charge they're going to get. Remember, they're trying to get a full shell, which is 8. If they can't get to 8, they just lose them. And the exception is this one guy right here, and that's helium. Helium is happy with 2. But because it's in this column, you already know it doesn't make an ion, so that should be easy to remember. Okay? So if you have any questions about valence electrons, oh, by the way, now's a good time to write a summary, maybe some more questions over here, especially about this part down here. That's a really good spot. Okay? If you have any questions about how this works, or you're not really sure how to figure out what ion it might make sure you ask your teacher. Thanks for watching.